Hey guys, Mr. Milton here. Today we're looking at evaluating functions notes. At the end of this video, you should be able to evaluate functions. Okay, recall from Unit 1, evaluate each function. So remember, evaluate just meant to substitute and simplify. So if I said evaluate this function, 4x plus 2, where x is 10, then say, okay, 4 times 10 plus 2, follow my order of operations, 40 plus 2 is 42. Evaluate y minus 4 over 3 for y equals 16. Well, then I'd substitute 16 for y minus 4 over 3. That's 12 over 3, and that would be 4. And then number 3, for x equals 2, remember that we have to plug that number in a parentheses. We're not just making it negative 82. Now it's negative 8 times 2, which is negative 16, minus 4, negative 20. And so if you can evaluate an expression, then you can evaluate a function. Okay, so we're going to be using function rules. And that's kind of what we've already done. So we're basically renaming something that we've seen before. And a function rule is just an expression that represents or describes a function. Okay, to write an equation in function notation, you only need to change the y to f of x. The f is not a variable. Okay, it represents the name of the function. And that way that when we have multiple functions that we're looking at the same time, we just say, look at f, look at g, look at h, okay? Instead of saying, look at y equals 3x minus 2, look at y equals negative 4x plus 6. Okay, it just makes it a little bit easier, especially when you label it as where you're having 3 or 4 different functions you're looking at simultaneously. So to make this function notation, we would just call this f of x equals 3x minus 2. I might say this is g of x equals negative 4x plus 6. Okay, and it basically is the function when x is in here. The function g when x is in. So it says, when evaluating function, you will see f of x being replaced with something like f of 2. And that simply means you need to replace x with the number 2 in the function. So here, number 1, it says f of x equals negative 5x plus 25. Find f of negative 2. And so then you go and say, okay, I'm looking for f of negative 2. F of negative 2, I substitute negative 2 every time I see x in parentheses. And then I evaluate. Or I evaluate that. Okay, so negative 5 times negative 2 is positive 10 plus 25. And this left side just stays the same. This is f when x is negative 2. This is f when x is negative 2. 35. And we're done. This is the answer. We've simplified it. And this says the function f when x is negative 2 is 35. Again, we are not trying to solve for f. Okay, this is the answer. This is a complete sentence. The function f when x is negative 2 is 35. Number 2, find f of 10. So I'll do that same thing. F of 10 equals, substitute 10 in here, minus 4. 10 squared is 100. The function when x is 10 is 96. And that's our answer. Here, let's get a little bit more complicated. So here we're given 2 functions, function f and a function g. It says find f of 8 plus g of 3. And it basically just says find what happens when we add the function f when x is 8 and the function g when x is 3. So here I'll do f of 8. And f of 8 is negative 8 plus 2. So negative 8 plus 2 is negative 6. The function g of 3 is 3 times 3 plus 4. So that's 9 plus 4, 13. So g of 3 is 13. So this says f of 8, which is negative 6, plus g of 3, which is 13. Negative 6 plus 13 equals 7. So f of 8 plus g of 3 is 7. Number 4, f of 2. So I'm going to plug 2 in here. 10 minus 6 is 4. Okay. G of 16, do it to G of 16, plugging in 16 here, 0.5 times 16 plus 7. So 1/2 times 16 is 8, plus 7 is 15. Ooh, I don't need to write that 1,000 times. 15. So G of 16 is 15. And so this says f of 2, which is 4, minus g of 16, which is 15. So 4 minus 15, and that gives us negative 11. So f of 2 minus g of 16 equals negative 11. And so here's our answer. Okay. So really, it's just substituting and simplifying. Substituting and simplifying. Here it says, evaluate the function rule to find the range of the function for the domain -4, 0, 3. And these instructions tend to confuse us just because they're telling us to do something that we know how to do in different words than we're used to hearing. So what this says is, I've given you 3 x values. In this case, -4, 0, and 3. And I'm asking you to give me the 3 y values to go with them. Okay, so evaluate the function rule. We're just saying, here's the equation. Plug in the values into the equation to find the y value of the function for the x values, -4, 0, and 3. Okay, so here's what we do with that. We'd say, okay, plug in our values. 2 times -4 minus 15. So that would be -8 minus 15. Absolute value, that's 8 minus 15, so -7. Boom. And that's f of -4. Okay. We do the same thing for the other values. Of 0, plugging 0 in would be a lot easier here. So f of 0, 0 minus 15 would be, and that's just -15. And then for 3, plugging that in, we have f of 3 equals 2 times 3 minus 15, so 6 minus 15, which is -9. All right, and so I'm going to list these as a range because they asked me to find the range. So I'm going to list it as a range, and that's just going to be -15, -9, -7. Okay, and I always go least to greatest just to make sure I'm not repeating anything. I'll keep that pattern. Okay. And so this next one, I'm going to just change color so we don't run into thinking this one's with this one. Okay, so they're asking us to do the same thing here. Find the y values for the given x values. So f of 4, or -4, will give us -4 squared, which remember that's going to be positive, right? 16 plus 5, which is 21. So f of -4 is 21. The same thing with 0. 0 squared plus 5, that's 5. And then we have it with 3. F of 3, which is going to be 3 squared plus 5. So that's 9 plus 5 is 14. Okay, and so from least to greatest is how I do it. So I have 5, 14, 21. And there we have it. Those are our answers. All right. Completing a table. Oh, nope. A little bit higher. All right. It says evaluate the function rule to find the range of the function for the domain -6, 3, and 9. So again, same directions, different numbers. They're just asking us to use these. Find the y value of the function for the given x values. Plug these x values in and see what it comes out to be. So as we plug this in, we have, change it to f of x equals 3/2 x plus 1. And so now plug in my numbers. So f of -6 equals 3/2 times -6 plus 1. So that's -18 divided by 2, which is -9 plus 1, -8. F of -6 is -8. Okay, do the same thing with 3. F of 3 equals 3/2 times 3 plus 1. So that's 9/2, which is, I'll just say 4.5 plus 1, which is 5.5. So f of 3 is 5.5. And then f of 9, and that is here. Okay, so 3/2 times 9 plus 1 is 27 divided by 2, which is like 13.5 plus 1, which is 14.5. So f of 9 is 14.5. Okay, and so here are our values. What is it, least to greatest? So -8, 5.5, 14.5. Oops. Okay. Again, changing that blue just because there's a lot of writing here and I don't want you to get confused as we're going through it. Okay, so same thing here. Same values that we're plugging in, seeing what comes out. So f of -6 here is going to be -6 minus 1/2. So -6 minus 1 is -7/2. I'm going to leave this as a fraction, -7/2. You should be able to deal with both fraction and decimals. If we wanted to here, we could have written this as 9/2 rather than 4.5. Okay, so so I'm going to leave this as -7/2. Here, we'll do the same thing with 3. F of 3 equals 3, sorry, minus 1/2. So 3 minus 1 is 2. 2/2 is 1. F of 3 is just 1. And then here, f of 9 equals 9 minus 1/2. 9 minus 1 is 8. 8 divided by 2 is 4. Okay, and so I'm listing my values. I'll have -7/2, 1, 4. All right. And then finally it says to complete each of the following tables for the given function rule. This idea will be used in the next lesson, so it's a good idea to understand what's happening now. This is basically us looking at a function rule and then putting it in a table so that we can graph it typically, okay? Okay, but it's just the same thing. I'm plugging in x, seeing what my y is, plugging in my input, seeing what my output is, doing my domain, finding my range. Going through, plugging those values in. 1/2 times -4 minus 3. So that gives me -2 minus 3, -5. Then I'll do the same thing with -2. Okay. F of -2 equal 1/2 times -2 minus 3. So that's -1 minus 3, and that's -4. The 0 is a little bit easier here. That'll just be 0 minus 3, -3. And we can keep going. Or you can notice like, hey, every time we increase by 2, this decreases by, or increases by 1. Okay. There are patterns to this, and that's kind of the nice part about a function rule. 1/2 times 2 minus 3, that's 1 minus 3, and that's -2. Okay, and do the the same thing for this final time. 1/2 times 4 minus 3. That's 2 minus 3, and that's -1. All right. Patterns are nice, but make sure that you understand what's happening before you just jump to a pattern, because a lot of people will do two things and be like, oh, that's a pattern. It goes by one every time, or not understand that there is an importance to making sure that your pattern is established and you understand it before you just jump to the next thing. All right. Number 2. All right, so here we got 2/3 times -6 plus 4. So that's -12 over 3. And that's -4 plus 4 is 0. Boom. Okay, so do that same thing with 2/3 times -3 plus 4. And so that'll give us -6 over 3, which is -2. Plus 4 gives us 2. 0 is easy. 0 plus 4 is 4. 3, 2/3 times 3 plus 4. That's 6 over 3, which is 2, plus 4, which is 6. Okay, and f of 6 will give us 2/3 times 6 plus 4, or 12 divided by 3, which is 4, plus 4 is 8. Okay, here. Notice here that our negative is outside of our x. Okay, and so when we plug in our values, we will want to make sure we plug in our values in parentheses like we normally do, but at the same time, that negative's already there. So we have a negative out here, -3 squared plus 5. So the -3 squared will be 9, but this negative out here will still be -9. So -9 plus 5 is -4. That's f of -3. Do the same thing for f of -2. When we plug it in, we'll have -2 squared plus 5. And that's 4, -4 plus 5, or positive 1. F of -2 is positive 1. Okay, we'll do the same thing here with, I'm going to move up here so I don't have to scroll. F of 0, and that should be easy, right? 0 plus 5 is 5. F of 2, again, when we plug this in, it's going to be -2 squared plus 5, so that's -4 plus 5 is 1. And then f of 3 will be -3 squared plus 5, 9. -9 plus 5, and that's -4. So here are our values: -4, 1, 5, 1, -4. All right, so there you go. There's some functions. In our next lesson, we'll probably associate those with some graphs, but that's fine in the function we're using it. All right, see you.